1.6 Learning to evaluate algebraic expressions. Some vocabulary terms that we will get to throughout this presentation. Harrison Ford, the actor, was born in 1942. You can find out what year Harrison turned 18 by adding the year he was born to his age. So if I take 1942 and I add 18, I can find out the year he turned 18. In algebra, letters are often used to represent numbers. You can use a letter such as A to represent Harrison Ford's age when he turns A years old. The year will be 1942 plus A. The letter A has a value that can change or vary. When a letter represents a number that can vary, it is called a variable. The year 1954 is a constant because the number cannot change. When you were in kindergarten, you learned that 5 represented 5, and 5 still represents 5. It's constant. It will always be 5. An algebraic expression consists of one or more variables. It usually contains constants and operations. For example, 1942 plus A is an algebraic expression. That's what we used for Harrison Ford. Now the book changes to the year for Ron Howard turns a certain age, the other actor and director. So now we have this expression of 1954 plus different ages. So the age over on the left-hand column, 16, 18, 21, 36, and just A. The year born plus the age, so 1954 plus 16, 1954 plus 18, so on and so forth, to find the year over here on the right, the year that he turned that certain age. So my expression is just 1954 plus A, where A can vary. To evaluate an algebraic expression, substitute a number for the variable. So let's look at some substitution. Substitution is a lot like volleyball or football. In volleyball, the substitute player comes and stands at the line and the other player comes off the court to allow the substitute to come in. Same on football. If the quarterback's going to come out, the substitute quarterback comes out onto the field and the other quarterback comes off. In expressions, we kind of do the same thing. I have the expression k plus 9, and I'm going to substitute 5 for k. So anywhere that k occurs in the expression, I'm going to instead now have 5. So I have 5 plus 9, go ahead and add, and get an answer of 14. Notice k is gone. It's left the playing field, and it's not part of our expression. For example B, k equals 2. I'm going to use the same expression, k plus 9. But now I'm going to substitute 2 for k, so my expression now looks like 2 plus 9. Go ahead and add those together to get 11. Multiplication and division of variables can be written in several ways, as shown in the table. And I can do substitution the same way that I just did for addition and subtraction. However, there's lots of ways to write multiplication. I cannot have any arithmetic sign at all. That means to multiply. I can also just have parentheses around either the constant term or the variable, and that means to multiply. The dot, and then this x that we don't use very often anymore other than scientific notation and a few other applications. Division, I can use the division bar like a fraction, which is what we will use most often. I can use the division sign, or I can use the slant sign, and we will never use that in any of the examples that I do because it can get really confusing to differentiate between your numerator and denominator. When evaluating expressions, use the order of operations. We're going to get into some more complicated expressions here. So if I have 4x minus 3, I'm going to substitute x equals 2. Anywhere x occurs in that expression, I'm going to substitute 2. The x goes away, it's substituted off the playing field, and now I'm going to follow order of operations. First, I'm going to multiply. 4 times 2 is 8, and then I will do my subtraction. 8 minus 3 is 5. Again, for these examples, let's follow order of operations. For example B, s divided by 5 plus s. For s equal 15. I have s occurring more than once in my expression. Each time it occurs, I'm going to substitute 15 in for that variable. So now my expression looks like 15 divided by 5 plus 15. Following order of operations, let's divide first. 15 divided by 5 is 3, and add last. 3 plus 15 is 18. My example C, 5x squared plus 3x for x equal 2. Again, my variable occurs more than once, so every time it occurs in the expression, I'm going to substitute a 2 in for it. So now I have 5 times 2 squared plus 3 times 2. Following order of operations, let's do exponents first. 2 squared is 4. And now I can multiply. And since the multiplication, since they don't interact until I add, I can do the multiplication simultaneously. 5 times 4 is 20, and 3 times 2 is 6. And the last thing I'll do is add 26. One more example here. I have two variables this time. 6 divided by a plus 4 times b. For a equal 3 and b equal 2. Anytime a occurs, I'll substitute in a 3, and anytime b occurs, I will substitute in 2. So now I have 6 divided by 3 plus 4 times 2. Order of operations tells me to multiply or divide moving left to right, so I'm going to divide first. 6 divided by 3 is 2, multiply second, 4 times 2 is 8, and the last thing I'll do is add. 2 plus 8 is 10.